Hi, do you ever wonder what is a computer language? If you want to answer this question, then stay here. The software architect is going to explain this to you. First, we need to understand what is a computer. And yeah, I know, for sure you already know what a computer is, what it's used for, and how does a computer looks like. Actually, it doesn't matter if you are seeing this video in your cell phone, in your TV screen, in a tablet, or in your laptop. Whatever media you are using to watch this video, you are using a computer right now. But let's start from the beginning. When the first computer was created? Well, officially, the first computer was conceived by an English mathematician named Alan Turing in 1936. The Turing machine was more a concept than a real machine when it was originally conceived. During the World War II, Turing participated with a group of scientists to develop a real machine to be used to decrypt the secret messages the Nazis sent to their troops around the world. The most difficult part to decrypt the hidden messages from the Nazis was the fact that the set of rules used to hide their messages were changed every day. Therefore, the machine used to decrypt the hidden messages from the Nazis must be able to detect different hidden rules every day. This first computer was named the Bomb and was finished around 1939. The magic of the Turing machine, what it made the Turing machine different to any other machine existing in its time, is that this machine has the ability to be programmable. Or in other words, this machine has the ability to change the way it works by changing their algorithms. Before Turing machine, a typewriter can be only a typewriter, a telephone can be only a telephone, a radio can be only a radio, and so on. Now, you may be wondering, what is an algorithm? Well, an algorithm is a set of ordered steps that takes a numeric input and generates a numeric output. For example, let's say that we configure the Turing's machine to sum two numbers. Then, if the input was 2 and 3, the output will be 5. Easy, right? Now, assume that after we sum a lot of numbers, we decide that now our machine will no longer sum, but it will multiply the numbers. Then we change the configuration of the machine, and therefore the behavior of our machine will completely change. Now for the same input, let's say 2 and 3 again, the result will be 6 instead of 5. This is the most simple example of an algorithm, a one-step algorithm that takes two numbers and performs a simple arithmetic operation over them. The algorithms can have 1, 2, or a million of steps, but the core meaning is the same for all, a set of ordered steps to process numbers and get an output from them. In our days, the computers are so powerful that the change on their behavior are no longer as simple as change an arithmetic operation. But instead, we can change the behavior of our computers from a word processor to a music player, to a video game machine, to an image editor, and so on. The change of behavior in the computers is the core of what computers are. It's not about how powerful your laptop or your cell phone is. It's their ability to change its own behavior and usage that made the computers the powerful multipurpose tools that are today. Now, the next question to answer is, how do we change the behavior of a computer? And here is where the computer language comes in place. Obviously, since the creation of Turing's machine in 1939, a lot of time and a lot of innovation has passed to reach the moment in time when we are now. But from the Turing's machine to the modern computers nowadays, there was always a constant. And this constant is the way in which the computers, both modern and primitive, read and understand the instructions that we, the humans, use to tell them what to do. This basic set of instructions is named binary code or machine code. and is always a stream of on and off states or zeros and ones. Obviously, even for the smartest human alive, try to tell a modern computer how to behave and how to interact will be extremely difficult, for not saying impossible to tell if we try to communicate to the computer directly in a code based on zeros and ones. Instead, when a human programmer wants to instruct a computer how to behave, the programmer uses a programming language. There are different types of programming languages, but for simplicity, let's classify them in three categories: assembly language or low-level languages, compiler-dependent languages, and portable languages. Let's start with the most basic but complex type of language. The low-level languages or assembly languages provide some level of abstraction from the binary code to be somehow human-readable code, but still they are very complicated to understand, and even an expert programmer will have a hard time reading a low-level language. Low-level languages depends on the hardware architecture. Usually, each microchip manufacturer has its own assembly code or a combination of existing assembly codes to tell their processors what to do. This is the code that gives life to each microchip in your computer or in any other device like a mouse, a webcam, the memory chips in your cell phone, or the infrared device in your remote TV controller. In order to create a code in assembly language, you need to understand the hardware architecture of the device or chipset you are going to program. The assembly language, once it's written by a programmer, is transformed into a stream of on and off states or machine code by an assembler. Once the code is assembled, it's ready to be executed in the chipset. The connection of different chipsets into a circuit board is what makes a device to be alive. The different pieces of individual machine code that makes hardware pieces into a circuit board to communicate each other is what we call firmware. The second type of languages, the compiler-dependent languages like C or C++, are languages that have a higher level of abstraction from the machine code to be human-readable code. A human-readable code is one that is formed by numbers, letters, and known symbols. Once a programmer has written the code to execute, a piece of software named compiler will take the code written by the programmer, will check for possible errors, and, if everything goes fine, it will transform this human-readable code into assembly code. Some compilers like C or C++ compilers translate the human-readable code or source code directly to machine code, and they let the generation of assembly code just as an option for those programmers that want to optimize and debug code at assembly level. The compiler-dependent languages are those that are dependent of the operating system or the architecture itself. For example, if we compile a C source code in Windows operating system, the compiled code will not be properly executed in other operating systems like Linux or Unix. Furthermore, a compiler-dependent language depends not only on the operating system but in the kernel of the operating system, meaning that a C code compiled in Windows 7 will not necessarily will run fine in other Windows version. As an aside example, a code compiled in Linux operating system with kernel version X will not perform well on the same Linux operating system, but with kernel version Y. Sometimes even source code compiled in some operating system may fail if it's executed in another machine with the same operating system but different processor. The general rule for compiler-dependent languages and their compilers is that the generated binary code can be executed only in the same machine where it was compiled. The compiler-dependent languages are usually used to create pieces of software that we call drivers. As the name implies, a driver is a piece of software that transports communication from the low-level hardware or firmware to the operating system. Drivers are the vehicle that your operating system uses to communicate with the underlying hardware. And that is why a compiler-dependent language needs to be compiled in the same machine and under the same operating system in where the driver is supposed to run. The third kind of languages, or portable languages, are those that can be executed despite the machine in where the source code was compiled. This if a compiler is involved at all. These are the highest level languages, meaning that usually they are slower to perform, but they are much more easy to write, read, and understand by a human. The portable languages are those that use an intermediary between the compiled code and the operating system. This intermediary is usually named a virtual machine. A virtual machine is a piece of software usually coded in compile-dependent languages. The most common language used in virtual machine is Java. Java also uses a compiler to transform human-readable code to machine-readable code. The Java compiled code is a file or a set of files with a class file extension. These class files run inside a virtual machine, and then the virtual machine communicates with the underlying operating system to perform their task. Virtual machines are dependent on the architecture and the operating system in where they are running, meaning that a virtual machine for Windows will not run on Linux, Android, or iOS. But once we write a code in Java, for example, the compiled files or class files can be safely transported across different platforms and operating systems. This portability is very useful for modern programming, since programmers, once they write a code, let's say in Windows operating system in their local machines, they can just put their compiler code in servers that usually run on their Unix operating system, and the code will run there without need to recompile it. There are other types of high-level portable languages. These languages do not run inside a virtual machine, and therefore they do not use compilers. Instead, they run inside a different software. For example, we have JavaScript language that is a scripting language that runs inside a web browser. Or SQL that runs inside a relational database management system or RDBMS. An RDBMS is a software used to query data stored into a database. The same SQL language is used to create new data, delete existing data, or update existing data. When you hear about a database in any system or application, that database usually has its own internal routines coded in SQL languages. The portable languages offers an additional advantage. The advantage that the programmer does not need to focus on the low-level algorithms like disk space management or memory management. Instead, the high-level languages or portable languages allow the programmer to focus only in the functionality the programmer wants to code for the computer. As you may notice, these high-level languages are what allow us to create complex applications in relatively short time. Even the simplest web page or web application will take years and hundreds of programmers to be coded in assembly languages. But with high-level languages, the same task can be completed in hours or months, depending on the functionality of our application, of course. There is a fourth category of pseudo-languages. These are not computer languages per se, but it's important to mention them. These are what we call the markup languages. Markup languages are not programming languages, since they lack the main properties of a programming language. The main characteristic a markup language lacks of is that markup languages cannot be used to create algorithms. That is the root property of any programming language. The markup languages are just a structured text file used to classify and label its own content. Most common markup languages are HTML and XML. HTML is mostly used into web pages and is the text file your browser receives via an HTTP network protocol from a server in the internet to show you text, images, colors, videos, music, etc. XML, on the other hand, is mostly used by web services. Web services are a special way of communication between two different machines using HTTP protocol. Every time you buy a product in a marketing website, the website communicates with another banking system to process your payment. The communication between the marketing website and the payment processing side is done using a web service, and the information they exchange are usually XML files. Now that you know what is a computer language, you may be wondering how many of them exist and what are they used for? Well, there exist around 700 different kinds of computer languages. Most of them are no longer used since they were used to program in obsolete computer architectures. In here, we will list only the most important and non-programming languages as today. Please keep in mind this video was made on 2020, so there could be newer languages that will not be covered by this video. Also, for each language I'm going to describe, I'm going to mention only the most widely used for each one. The first one, the jewel of the crown, is Java. Java is mostly used to code backend servers and is widely used in the enterprise programming. All the big companies use Java to run their internal applications like accountability systems, inventory systems, web commerce, and so on. Java is also widely used to create mobile applications and programs for many types of devices. C and C++ are used in the video game industry for consoles, mobile gaming, and PC gaming. C and C++ are also used to create advanced desktop applications like image editors, video creation software, office-oriented software, and drivers for a wide set of components and devices. JavaScript is a language that runs only inside a web browser. It's mostly used to create dynamic web pages with rich functionality. Every time you visit a web page in the internet, it's almost sure that the web page you are visiting uses JavaScript code that is executed in your web browser every time you perform an action, like clicking on a button or validating the data inside a form that is going to be submitted. Python is a multi-purpose language. It's mostly used for data science applications, Unix servers routines, financial applications, and statistical applications. Python is also used to generate dynamic web pages and some very common web applications with desktop interfaces like BitTorrent or Spotify. C# is a programming language created by Microsoft. It was an intent to emulate C++ languages, with the difference that a code written in C# is heavily tied to .NET framework that is a Microsoft product. However, C# can also be used to code mobile applications for Android and iOS. The main difference between C# and C++ is that while C++ is a compiler-dependent language, C# can be considered a high-level language since it uses Microsoft .NET Framework as an intermediary between the compiled code and the operating system. PHP is a language that was widely used in the 90s to generate dynamic web pages. PHP has been replaced by Java over the time. However, I mention PHP since this language was a great contributor to the internet ecosystem during the 90s. And even when most of PHP pages are now running under Java, you can still finding a lot of modern websites that run all or part of their web generation in PHP. As mentioned earlier, SQL or Structured Query Language is a programming language that is used to code functionality and routines inside databases. Even when there are a lot of different databases and each one of them use their own specific variation of SQL, the most of the syntax for all databases is based on ANSI SQL. There are a lot of other programming languages out there. Here I'm just mentioning the most used for the year 2020 and their most common usage. So, thanks for watching. I really hope you enjoyed this video. If you liked the video, please like, subscribe, and share. Have a good one.